I don't know about you, I learned a lot today, from drug discovery to the wonderful, interesting NASA project, robots, and also the industry experts about whole industry development and stories, beauty stories. Thank you so much. My background is mathematics. I got a degree, bachelor degree in mathematics and a master in MAICHS and PhD in marketing. So today, I will not convince you, but add one more example. Why AI is so wonderful today and represents, like Victor just mentioned, it's going to be revolutionary and it will influence every industries in today. So mine is more about something. By the way, I'm not an AI expert, but I use AI in my research. Today I will talk about consumer music popularity with the AI methods. Just now we had a wonderful time, but today I'd like to be a little bit interactive. Okay, so for example, can I say everyone enjoy music, right?
Yes.
Wonderful. Okay, great. How many of you have an experience on stage performing music? Oh, wonderful. Wow, great. So, if one day you could influence the music, let me show you the introduction here. Next. Okay. Not long ago, how many of you heard Taylor Swift? Okay, everybody. So she's this number one today, most popular singer. But however, have you heard a singer Raymond Liu? No. So based on long tail theory, singers, musicians who are on the left side, very popular, a lot of fans in the audience. But the tail gets very long, very long, very long. And some musicians are not so popular, less popular. And then get the very end, very blue. Okay. So later I will show you how my music is. Okay. But the question is, when you are middle or the end, do you want to be more famous? Of course, right? So, for example, not everyone is a fan for Taylor Swift. You may have your own. A lot of people enjoy it. For example, I like, by the way, unfortunately, I like classical, like opera. Not many people like that, right? But if I would like to make classical music or opera music more popular, what should I do? In other words, what makes a song, a singer, popular? And I'm interested in music myself, so traditionally I use a lot of traditional statistics to analyze the data and find what are the most important factors. However, today, with the availability of big data, when I say, for example, I want to understand what is in your mind, why do you like this music? If I ask those questions, I can do different ways of doing this. One way, for example, survey, experiment. And then, my data will be like several hundred, the most. 1,000 is hard. But now, with the Spotify, streaming data, streaming music, we get millions or even more. And how do we analyze those data, get a meaningful out of it? That's the beauty of AI. And I will talk more about why traditional music has some limitations. For example, for traditional statistics, they are very powerful as well. However, I don't know how many of you have statistics. Wonderful. So, for example, in statistics, you probably notice that when your sample size increase, some of the statistics, for example, correlation, usually getting significant, but the coefficient is getting smaller because I'm sometimes big. So when the coefficient getting quite small, it's for example only 0.0 something, then real meaning is limited. Okay, so that's something with the traditional statistics. And still, with traditional statistics, you think about we based on a lot of linear model. By the way, anyone do not understand what is the linear model? Okay, wonderful. Okay, linear means y equal to ax plus b, only 1x, power of 1, linear. The question is that a good model? You know, most of it is traditional statistics based on linear model. But the question is, when we think about this, then we have some limitations. What if the phenomenon in the real world is not linear? You know, if you study advanced calculus, you probably have noticed in Taylor series, Taylor equations, they use the first power of 1 linear model to express any function, no matter if it's linear or not. But this is only within certain range. You can limit, you can approximate within linear model. Otherwise, you won't be able to. Now, in my following example, I will using Spotify data and understand what exactly we can do for music. Excuse me. How do I move? Okay. Okay. So for Spotify, I'm sure you understand Spotify. Basically, it's a streaming service. They have, recently they are getting more and more popular, and the revenue is 25 billion in 2021. And we got data very recent last year. So in the data, we're fortunate to have some variables. We call it popularity, for example. I will explain more later on. Okay. And so in this data, before we go further, we did some literature research about what we did in the literature, other people did in terms of music popularity research. Including myself, in 2017, Dr. Zhang and I published a paper on using how social media to use some music brand name. That's another way to make people in this stage move up. But anyway, so all this research we find out, they either way, either using Spotify data or not using Spotify data. The one thing I found is interesting is about what it really caused popularity. What do you mean by popularity? In Spotify, they define from 0 to 100. 100 means most popular. Okay, so I'm sure Taylor Swift will be 100, and Raymond Liu will be almost 0. It's okay, but the question is, what are the factors that can affect your popularity? That's the most important thing. Then we did get the data. They have some information about, for example, I want you to think about carefully. When you listen to music, what are the things you really, really think play important roles out there? For example, energy level. When you hear music, you feel like, wow. You feel you are motivated, energy level high. And some of the music can make you feel like you're moving, you're dancing. The rhythm, the music make you feel lively. So this is the measure as well. And some music are more, we call it speechiness, for example, rock. Okay, those music they have a rhythm, but more in speech type. So anyway, we have many measures like this. For example, we have I just introduced a few. Actually, we have quite a few measures like this. Besides danceability, energy, and instrumentality classical and so forth, with different type of music. And one of the things I noticed in previous research, they did not include the G-rate inside. But actually, in our study, we find that this is a mistake. We have to include that. Just how I mentioned the limitation of the traditional statistics. So we use with big data, the AI is really helpful. Okay, I use 12 different AI methods. Today I'm not going to go to each method, but basically most of them are very helpful. It's more, we call it supervised learning, supervised machine learning methods. But the results is very exciting. Okay, and we use 12 different methods. Okay, I'm dealing with balanced, unbalanced data, and also different ways. I'm going to go to the result part. So we use the 4 different measures to see the overall model performance. And from here, I don't know if you can see the table. This is wonderful. Okay. So you see here that for obvious, when forests outperform any others. So no matter in which measure, 93, 87, 93, and 90, they are all above the others. So from our findings, the random forest is the best so far. So in terms of the measurement, I'm not going to go over, but it's basically they are measured like this. Okay, we'll skip this part. But one thing what's very exciting is for previous literature, they ignored G-rate, take it for granted. But we found from all 12 different methods, we found overall data protected together. G-rate is the most important one. If you think about it, it makes sense though. For example, in the first slides I did on Google search and ChatGPT search, who are the most top 5 singers. And 4 of them, pop musicians, pop singers. So, why is that? And so, in other words, depends on what type of music you sing. That makes it very important. Unfortunately, the question is, okay, Raymond, you said you're a singer, and you sing opera. But if I ask you to sing some pop songs, I would say, no way. I don't think I can sing that. So it's very difficult. But in the history, we find some exceptions. For example, how many of you heard of Bob Dylan? Bob Dylan. He's the only one got a Nobel Prize as a singer. Nobel Prize singer. Okay, so and his background, when he started to sing, he was singing folk music. And little by little, it's kind of a combination of rock and folk and singer-songwriter and some other things. And especially, he was very into songwriting. So he got a Nobel Prize because of the songs he wrote. Anyway, so this was one example. It's exception. Cross G-rate. And that's a very smart way of doing this. By the way, I'll list the top five. It's okay, I can see no. Top five singers. Number 4 is across G-rate. Not only just pop, but also rock. So anyway, this is one example. Another example, I noticed, how many of you have seen this Phantom Opera? You heard that? Okay. Sarah Brightman, she was basically, Phantom Opera is a Broadway show, it's a music show, but not a real opera. However, Sarah Brightman was trained to ensure they are trained in classroom opera music type. So that's why it's kind of a cross-genre as well. Okay. So this is the example. Now the question is, not everyone is so gifted, not so trained. So then what are you going to do? For example, let's say, quick. So let's say if I like Raymond, I only sing opera songs. So what are you going to do? So what we do is, in other words, we use AI to analyze under each genre. What are the factors play important roles? You can see at different genres, the factors' importance are different. That's another important finding. So in other words, no matter what you are specializing in your area, you need to make sure, according to our findings, in each area you emphasize the more important. For example, children's music, you probably emphasize the duration, but for soundtrack, you probably more emphasize instrumentation, instruments. So it will be different. I'll go quick. Sorry. Time goes so fast. Okay? How many minutes? Okay. 20 minutes left? Okay, I'll go quick. So basically, what I think is this is based on this study, and I added one more example showing why AI is so useful, and sometimes traditional tools may not be helpful, but AI is out there. I'm sure we can discover more things in different industries. Before we end my speech, I would really like to show you why my music is not helpful. Okay? Okay, I'm going to sing that song, Tora Solietto. Last year I went to Italy and sing the Italian song, and a lot of people give me applause. Hopefully you give